Okay, welcome to this video on inverse relations and functions. The things that we'll be talking about today are finding inverses of relations, graphing inverse relations, determining whether functions are one-to-one, and graphing those formulas of inverses that are one-to-one. So first off, what in the world is an inverse relation or an inverse function? Here's how you can find them. An inverse relation can be obtained by switching the x and y coordinates in an ordered pairs, or by interchanging the x and y variables in an equation. So for example, here is a example of some ordered pairs. If I wanted to write the inverse relation that corresponds with this, I would simply take each of the x and y values and switch them or interchange them. So there's that one. The next one would be 5, 3. The next one would be 7 minus 2. And the last one would be a, b. So that would be the inverse relation to those ordered pairs. Now, if I have an equation like this, y equals 2x minus 3, that's a line, a linear function. If I wanted to find the inverse of that, I would simply swap the values or swap the variables of x and y. So I have that. Now, with inverse relations, or with any relation or any equation, typically we always write them as y equals something. So it makes sense for us to take this one and change it from x equals to y equals. So to do that, I'll add 3 to both sides. And then I'll divide every term in the equation by 2. So I'll have x over 2 plus 3 over 2 is equal to y. So this here would be the equation of the inverse relation to this one here. Now, when we look at ordered pairs and we look at the graphs of them, an interesting thing happens. In taking a look at this graph, it might be a little small there for you. Let's make it a bit bigger. The points in red, I guess all of these points here are, I believe, the points that are listed up here. And the points down below here are the inverses of each of those. So 2, 4, 2, 4, that's the blue one. The inverse of that is 4, 2, of course. And that is 4, 2, the blue one here. What I wanted to draw out from this is that take a look at how these points are lined up in relation to this line here. This line has as its equation y is equal to x. Notice that it seems like the points are always the same distance away from that y equals x line. So y equals x is like the reflection line for inverse functions. And we'll see that that's true for lots of them. Let's look at an equation of a line. Here's our equation, y equals 2x minus 3. Recall that we found the inverse of that to be y is equal to x over 2 plus 3 over 2, I think it was. Let me switch back there just a minute. X over 2 plus 3 over 2, yep. Okay, so here is the equation of the inverse, and I've graphed both of those down here. So here's the graph of y equals 2x minus 3. Here's the graph of its inverse. And take a look here. This is our line y equals x. That each of these functions are mirrored over that line. So the line y equals x mirrors inverse relations. Now, when I'm talking about inverse functions, or the difference between a function and a relation, the idea of one-to-one versus one-to-many comes up. You'll recall that the definition of a function is in relation to a graph would be any graph where a vertical line can cross it only once. So for example, a parabola. A vertical line only ever crosses a parabola once. If I have a sideways parabola like that, and if I draw a vertical line, it crosses it twice, making it not a function. So for every value of x, I must only have one y value. That's the idea of the one to 1 versus 1 to many, many to 1. Anyway, when I take a look at examples of one-to-one functions, here would be a few of them. Students and an ID number. There's only, if I have one student, they will have one ID number. There's no way I can have two students with the same ID number. Or, to have one ID number refer to two students, that doesn't make sense. Same thing with people and bank accounts. If I know the bank account, I know the person to which that belongs. Same thing with people and fingerprint. Now here, this is a different one. A person and their favorite sports team. I guess I could have lots of people that have one particular sports team as their favorite. So this might be a many-to-one function. Here, people with passwords. That one again, I think maybe there might be many people that have the same password. Fortunately, you won't know who else has the same password as you. An example of one-to-many, that would be a good one. You could maybe think about those. At any rate, the ones where, when we're looking at inverse functions, the ones that are inverse functions, or functions when you take the inverse of them, are always one-to-one. If I have a function already that's one-to-one, its inverse will also be one-to-one. And that's what I've stated up at the top. If a function is one-to-one, then its inverse is also a function. So, to take and get the formula for an inverse function, here's some steps that can take you from a functional notation of a function, and then it'll switch it to the functional notation of its inverse. The first thing you want to do is change the functional notation to simply y is equal to 3x minus 5. Okay, so change the f of x to y. Then you interchange the x and y values, so x is equal to 3y minus 5. And then solve this equation for y. So I'll add 5 to both sides, and then I'll divide everything by 3. So I'll have x over 3 plus 5 over 3 is equal to y. Then, lastly, change the y to f minus 1 of x. This f minus 1 indicates that it's the inverse function. So it's our notation that we'll use for an inverse function. So if f of x is equal to 3x minus 5, its inverse is equal to x over 3 plus 5 over 3. So the concept that we just briefly went through today was the inverse of a relation or inverse of a function. To do inverse of functions, you swap the values for x and y and then solve for y. This will be important when we start looking in this section at exponential and logarithmic functions, as they are inverses of each other.